Hey students, tired of circuit that looks like spider web? What if I told you there is an easy trick to solve any series parallel combo under 2 minutes and score full marks in exam? Was till end for the bonus trick and hit like if you are ready to crush physics. So let us start. So in 10th board examination there is a very important chapter, electricity. Electricity, some of the numericals will be asked. Let us have a quick recap of the electricity chapter very quickly. Electricity start with the charge. Charge is the very fundamental property, and electrons have the negative charge, which is having minus 1.6 into 10 raised to minus 19 coulomb charge, as whereas protons have the positive 1.6 into 10 raised to minus 19 coulomb charge. And the flow of charges is nothing but the rate of flow of charges is nothing but the electric current. The first formula is here, I is equal to Q by T. Here you can use the quantization formula here for charge. So this will become I is equal to Q by T equals to NE by T. You can use this formula to identify the number of charges. E is the charge on the electrons, or it is the basic charge. So from here we will see that there are a few of the units. What is the unit of the current and the definition of the current? So SI unit of the current is the ampere, and it is defined as when the 1 coulomb charge flows for per second. So 1 ampere is equivalent to the 1 coulomb per second. But ampere is the very biggest unit, so you have to use the sum of the smaller units, and the smaller units are like 1 ampere and microampere. 1 microampere is equivalent 1 microampere is equivalent to 10 raised to minus 6 ampere, and 1 milliampere is equivalent to 10 raised to minus 3 ampere. When you have to convert from milliampere to ampere, you have to multiply by 10 raised to minus 3. And current have the two types. One is the DC current, that is the direct current, and other is the alternating or the varying current. You most of the for the 10th board mostly deal with the direct current. So direct current, if you plot it against the time, the direct current value is the constant value with respect to time, but the alternating current, its value changes alternatively over the period of time. Then the next important term is the electric potential, and it says that it is the work done in bringing unit positive charge from reference point or from the infinity to the given point, that will be considered as the electric potential. And the formula for here, the potential is work done per unit charge. Now these symbols are also very important. Most of the old books uses this symbol. Now this symbol is a little bit quite obsoleted, and the new symbols, in some of the references you might see there is a rectangular box and some value of the register is written over here. This symbol is also correct. Rheostat or the variable resistance will be like this. Ammeter is the device which measures the current. This ammeter is always connected in series, and this voltmeter is always connected in parallel. So series parallel arrangement we are going to see. Galvanometer is the name of the instrument which should detect the current. Very feeble current can be also detected with the help of galvanometer, and AC source is denoted by this symbol. You already know the symbol for the device which provide the potential difference across the circuit is the cell or battery. Cell is just the two lines, and battery is the combinations of two or more cells. Now here the important parameter is again there, resistivity. Ohm's law you already know, so that I am not going to discuss it. Ohm's law says that potential difference is directly proportional to the current, or vice versa it is also true if temperature remains constant. So here the formula becomes for the Ohm's law is V is equal to IR, and here R is equal to V upon I. This ratio is always constant, V upon I. But this R resistance depends on some of the factors, and these factors are length of the conductor. It varies directly, and it is inversely proportional to the area of cross sections, and that proportionality constant is taken as rho, which is nothing but resistivity of that material. It is a very special feature. Now What is the effect of temperature on the different kind of material? So first diagram you are looking at, it is for the conductors. For conductors, if the temperature increases, the resistivity will always increase linearly with the temperature. And for the semiconductor, it is a very special kind of materials. For semiconductor, the behavior is different. If the temperature is increasing, then its resistivity go on decreasing, because the number of charges by increasing the temperature which flows through that semiconducting material becomes more. And the resistivity for the insulating materials, its behavior with the temperature will be like this, of this nature. As temperature increases, the resistivity also increases in that way. So application based question will be asked to you, and in the application of the heating effect or the Joule's law, this is one of the important appliances for the safety measure. Electric fuse, it is always connected in series, always remember that. It is connected in the live wire. Live wire is shown by the red color only. And fuse has a very special characteristics because it has a low melting point, and when the high current flows through it melt down easily. They are generally made of copper or tin lead alloy. Tin lead alloy are commonly used to make the electric fuse. So it works on the heating effect of the currents. As per the Joule's law of heating, the heat produced is directly proportional to the square of the current, resistance of that conductor or the fuse, and the time for which it passes. So here, due to this heat, when the high current passes, the fuse wires get built down and circuit is broken, so that it stops any further damage, or it avoids the burning of the electric circuit as well. Now we are coming to the most important part of this video, how to solve the electric circuit. So don't be afraid, let us simplify it. I am coming with few of the examples which already asked in the previous board examinations. For example, this is the problem came in the Delhi CBSE board 2009. It says that two resistors with the resistance 5 ohm and the 10 ohm respectively are connected to the battery of EMF 6 volt, so as to obtain the minimum current, maximum current, and along with that the two more questions are that. Let us see or simplify it. I always says to the students, whenever there is any numerical, you must focus on the given data first. So what is the given data here? Let us assume there are the two resistors. Let us assume these resistors are like R1 of 5 ohm and R2 is of 10 ohm. And in physics, imagination is more important. So let us draw the circuit with the given data. As already mentioned, here there are the two resistors and they are connected to a battery, and there are two conditions are given, minimum current and maximum current. So in order to obtain these conditions, we have to connect those resistors in a particular arrangement, and we know already that how that arrangement can be. So how will you connect the resistance in the each case? For the first case means minimum current, the resistance must be higher, and we already know that if resistors are connected in series, the resistance automatically get added up and it become maximum. So for the first conditions, the arrangement is the series one. So first one is the arrangement is the series one, and for the second arrangement, that is the second case, the arrangement will be parallel, because when the resistors are connected in parallel, their value decreases. And if the resistance decreases, the current will be maximum. So remember that. So here in the second conditions, we have to arrange the R1 and R2 in parallel arrangement. And we already have given that all these resistors are connected to a battery of EMF 6 volts. So the battery here, let us connect this with a switch of 6 volt battery. Here again 6 volt battery, along with the switch we will connect it 6 volt plus minus. So let us analyze this circuit step by step. Calculate, and the question asked here. So here for answer of this A part is basically the diagram itself. The resistors are connected in series to obtain the maximum current, and resistors are connected parallel to obtain the minimum current. So this is the answer of the first A part. Now let us focus on the B part. Calculate the strength of the total current in the circuit in two cases. So we have to calculate the total current here, and we are going to use the same formula as per the Ohm's law. Total current will be equals to the total voltage or potential difference across the circuit upon total resistance of the circuit. Very easy. So already we have this data that the V total will be the 6 volt. Now we have to just calculate the R total, and as you know, series circuit are very simple, so we have to directly add up them. The value of the total resistors, by adding these two we will get the total resistance as 15 ohm. So we will get the total current in the series one, that means the first case will be equals to the 6 volt upon 15 ohm, which gives the answers in the rational number form as 16 by 6 by 15 ampere. So it's quite easy. Now in the second case, if you check it out, this R1 and R2 are in parallel, and if I suggest you, it is a very simple method. When any two resistors are connected in parallel, if you want direct answer, just do this. To obtain the effective parallel resistance, just take the product of both the resistors and divide it by their sum. Very easy. So what is the product? It is R1 into R2 upon R1 plus R2. If you go by the traditional method also, you can reach to this formula directly. So we are going to here in the parallel arrangement, as the resistors are, R1 value is 5 and it is the 10. Now most crucial part of this video, I am going to provide a trick by which you can identify the value of effective resistance directly. But as you are appearing for the board examination, you have to give the descriptive answers. So that is why we are going by the traditional method first. So here, as per the traditional methods, 1 upon Rp, which is our traditional formula for the parallel combinations of the resistors, 1 upon Rp plus is equal to 1 upon R1 plus 1 upon R2. So if you substitute the value 1 upon Rp is equal to 1 upon 5 plus 1 upon 10, you will get the same output as like this. So here we will get 50 upon 15. If you simplify it with the help of 5, table of 5, it will be the 10 by 3 ohm. Now this is the point where I am going to share you the bonus trick for this video. First concentrate on this circuit. Suppose if you have the two resistors in series which are having the values like this, X and 2X ohm, means there is one resistance having a particular value and its parallel resistance having double value of it. So its effective resistance is given by 2x by 3. This is your direct answer. So we have given the first resistance was the 5 ohm and the another resistance was the 10 ohm. If you directly substitute here the 2x value is 10 ohm. So the RP, that is the parallel resistance, effective resistance, is 10 by 3 ohm. This is the direct answer. Isn't it amazing? If you go traditionally, of course it will take time to solve this, but just within few seconds, if the two resistors are given in a such a way that the one resistance is value x and the other resistance is the 2x, this method is applicable only when the resistors is having parallel combinations, one double another. Then you can directly use this formula for effective resistance as 2x by 3. Means you have to just make the one third of bigger or the double resistor. Isn't it amazing? So let us apply this method. So by applying this method, we got the value of the total resistor as 10 by 3. So we have to calculate the total current here. So I total will be equals to the V total upon R total which is our effective resistance. So V total was here 6 volts and here the R value is 10 by 3 ohm. Denominator becomes the numerator, so it becomes 6 into 3 by 10 which is equal to 18 by 10 which is nothing but 1.8 ampere, and this is the largest current flowing through the parallel circuit. In case B, the strength of the current will be the 1.8 ampere. This is your answer. So are you ready for the next problem? So let us see another problem which was asked previously in the board exam itself. So here now 3 resistors are connected in parallel. We have to calculate the current through each resistor, then total current in the circuit and the total effective resistance of the circuit. As I already told you, you can see here there is a one resistor of 5 ohm and another resistance of 10 ohm. So once double 2 is such kind of arrangement is there, so that can become, look at this, the resistance become like this. This will be the 2 ohm as it is, and the combination of the 5 and 10, it will become 10 by 3 ohm. As I already told, if there is one resistance of value x and the other resistance of value 2x connected in parallel, then their effective resistance becomes 1/3 of the bigger resistors. So it is a 10 by 3 ohm. Now one more simple trick I am going to tell you regarding the parallel resistors. If there are odd values of the parallel resistance R1 and R2, just I previously told you, the effective resistor is just the product of the resistor divided by the sum of the resistors. So here you will get the product of resistors 2 into 10 by 3 upon 2 plus 10 by 3. So what will be the value here? RP will become 20 by 3 upon, here if we cross multiply, 6 plus 10 divided by 3. So here this 3 will get cancelled out. So the answer we are getting here as 20 upon 16. After simplifications it becomes 10 by 8 or 5 by 4, which is nothing but 1/4 ohm or 1.25 ohm. This is the effective or the total resistor of the circuit. Here one more thing I will tell you. If you see, always try to generalize the values or the answers from the parallel combination you will always get the effective resistance in the parallel combination always less than the individual resistors. So for parallel generally, for parallel resistors, this Rp value is less than the individual resistor. Rp is less than R1, Rp is less than R2. After even the calculations, if you are getting the value, you can tally your answer. If its answer is individually greater than R1 or R2, then you are wrong. For parallel combination, the effective resistance is always less than their individual resistances. So this is the actually the third answer we found for the total effective resistance. It is 1.25 ohm. And if you get this value, means this circuit will be replaced by such kind of resistor which is having value just 1.24. So let us replace that circuit with those values. Now the effective resistance is 1.25 ohm and it is now connected to the 6 volt battery. So we are getting 1.25 or 5 by 4. You can use the rational form of the values as well to get the answers. Now current through each resistors. We already know if there is a parallel arrangement, the current through each resistor will be different. So let us assume that from 2 ohm resistors the current is I1, from 5 ohm resistor the current is I2, and from 10 ohm resistor current is I3. But the potential difference across each resistance is same. In parallel combination, potential difference across each resistance is same. So we are going from C to B now. So calculating the total current, we already saw that formula. Total current is equal to the V total, that is the total potential difference applied, upon R total, that is the total resistance of the circuit. So we already know that here the 6 volt battery is there, which is the V voltage applied, and the R total is 5 by 4. Denominators goes to the numerator, so it is become it is like 6 into 4 upon 5, which is equal to 24 by 5. So the answer is 4 whole 4 as to 5 ampere, or we can say that it is a 4.8 ampere. The current, total current is 4.8 ampere. So if you check it out, this total current is 4.8 ampere I. Now this current is splitted as I1, I2 and I3. But we already know that through each resistors, for example this 2 ohm, this 5 ohm, and we have to calculate the current through this 10 ohm from each resistor. We know that the current entering here is 4.8 ampere, but the potential difference applied across it is the 6 volt. So if it is R1, then potential difference is always same. So let us assume that V will be equals to I1 R1. So we know I1 value we have to find out, R1 we already know 2. So the value of I1 will be equals to 6 by 2, which is equal to 3 ampere. This is the current passing through the resistor 2 ohm. I2 on the same basis formula, V upon R2. So it is 6 upon 5, which is equal to 1.2 ampere. And if you check out I3, it will be V upon R3. It will 10 by R3 value is 10, which is equal to 1 ampere. If you add them all, what you are getting? 3 plus 1.2 plus 1. If you check it out, so here whatever the value we are getting as I total, so 4.8 ampere here it is 3 ampere, here it is 1.2 ampere and 1 ampere.